Today I discuss one important topics related to normed linear space. We know about many spaces, LP space, L infinity space, subsequent space, and obviously CAV continuous function space, BAV bounded function space, and other spaces also function space. But today we discuss L infinity space. Obviously, L infinity space the set of all bounded sequence on any field K, and obviously we define one norm infinity and prove that L infinity norm be a Banach space. Okay, we start from that. So we write here this theorem first. The space L infinity, or the L infinity space of all bounded sequences in K, okay, with infinity, with the norm infinity equal to supremum of x in where n belongs to natural number, where x belongs to L infinity, be a Banach space. Okay, be a Banach space. So the space L infinity be a Banach space. We now prove that. Which space is Banach? We know about that. One complete norm space is Banach space. Complete norm space sense in the sense some Cauchy sequence in the space convergent in this space. Okay, and norm space we also know about that. So we're now going to be proof of that. Now we know about that L infinity norm infinity be a norm space. We also proved in previous class. Okay, so now we prove next portion of that. So we start from that L infinity norm infinity be a normed space. So we have to show that. L infinity norm infinity be a Banach space. So how we show that is any Cauchy sequence in L infinity must be converged in L infinity. We have to prove that. Okay, so how we prove this? To easily we prove this, just for this, let xn be a sequence, xn be a Cauchy sequence. Okay, this one x to the power n naught, we just marked its suffix x. Okay, so xn be a Cauchy sequence. That means we write it in below, but here we write it in above. Okay, so this one is Cauchy sequence in L infinity. Then what happened? Then how this one is, that means how we write this one, x here, if x in 1 2 dot 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 in, then x1, how x1 is denoted, x1 denoted in this way, x1 dot, sorry, x1 1 here, x2 1, x3 1 dot dot dot, x in 1 dot dot dot. Okay, or here we write xk, then not a problem at all. Okay, any integer. So again we write this one, and dot 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 here x n equal to what? x1 n, x2 n, x3 n, dot 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 x k n, dot dot dot. Okay, so all are belonging to L infinity. Okay, belonging to L infinity means what? Means norm of this term, maximum of norm of or supremum of norm of this term, this modulus term, obviously less than plus infinity. Okay, so we now prove that this one Cauchy sequence be a Cauchy sequence, and how this sequence is arise we also write here. And now we're going to discussion about that. That means criteria of Cauchy sequence. We erase our portion and going to further discussion about that. Okay, so we now erase that portion and going to further discussion of that. We know about that simply Cauchy sequence, that means by definition xn be a Cauchy sequence, so let epsilon greater than 0 be given or be chosen. Okay, let epsilon be chosen. Then what happened? Then since xn be Cauchy, then what? There exists n0 belongs to natural number such that what? Such that norm of xn difference xm less with respect to norm infinity less than epsilon. Okay, for all mn greater than equal to n0. I understand. Any problem here? Oh, some problem occur in fixed chat. That means in video also some problem occur. I think this one is removed now. Okay, so we'll start from that portion. Okay, so we start from that portion. Why this, that means problem occur, we don't know, but this one I think now remove. We also start from that. Okay, so what we write now? We write here that portion supremum of k belongs to n, this one modulus of xk whole to the power m difference xk, sorry, here n, here m. Okay, not a problem at all. Anything mn we written here, this less than epsilon. Okay, so next what happened? Next this implies that means why we write here, why we write this. If we elaborate this one, then this one happened in this way. Okay, we write it here x1 in difference x1m and x2 in difference x2m in this way. Okay, then supremum of any of them, here we write k belongs to n. If we write here verses, second verses or not, this one not a problem at all. Okay, so certain problem in creating video, I think who create those problem I don't know, but some persons are create those problems. Okay, this problem is now vanished. Now start from again. Okay, so this one supremum of k belongs to n mod of xk whole to the power n difference xk whole to the power n less than epsilon. So this one is not needed now. Okay, now we're going to further discussion of that. Supremum of this less than epsilon, that means that this less than epsilon. Okay, Obviously we write here for all m(n) greater than n0, we write here for all n(n) greater than n0, and we write here in this way a k belongs to this natural number. Okay, I think not a problem at all. So we again going to hence for each k belongs to n, each k belongs to this natural number xk whole to the power n. Okay, here k equal to, sorry, here n equal to 1 to infinity, be a Cauchy sequence, sequence in where xk, that means just single entity. Okay, if we considered infinity tafel, because here in L infinity this sequence, this one entity is contained, or one element is contained, that means n tafels, sorry, infinity tafel. So this one just one from this infinity tafel. Okay, so this one belongs to where, this one Cauchy sequence in any field k. Okay, so we know about that. What we know about that? Since any field we complete, we know about that. So what happened? Any field we complete means limit limit n tending to infinity xk whole to the power n obviously converts, and converts to xk belongs to what? Belongs to this k, because k is complete. Understand or not? I think understand. Okay, so we define in this way, k be complete, so any Cauchy sequence we write it here, any Cauchy sequence in k, it must be converged. Any Cauchy sequence in k must converge in k. Okay, not a problem at all. K sum failed, so this one complete, so this one happened. Now we also take what? Take x equal to x1 x2 dot 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 xk dot dot dot. Okay, where this element belong? Obviously this x belongs to L infinity, and each element belongs to this k. Okay, now we're going to this one be a that means some element in L infinity. Now we considered what? We considered that, that means we considered it in a sequence. Okay, x equal to xk, k equal to 1 to infinity is in k. Then what happened? Then we have to show that, xn Cauchy and it, that means xn Cauchy, hence it is bounded. Okay, and this x what? This x must be, that means bounded. First we saw about that. Okay, that means this x, sorry, we take this one is not, we take x equal to that. Okay, but we have to show that what? We have to show that x belongs to L infinity. Then this L infinity must be complete and X infinity be Banach space. Okay, so what happened? Every x belongs to L infinity, we have to show that x belongs to, if we show x belongs to L infinity, then proof is done. Okay, so how we show x belongs to L infinity? First we have to show that every element of x must be bounded. Okay, then this supremum is bounded, then obviously x belongs to L infinity. So what we do in this way, we know about that. So what we known here, we known here xn must converge to x. and we know about that xn belongs to L infinity and xn b cos c. Okay, we know this portion now. Any problem here? I think not a problem at all. Okay, I think not a problem at all. Here we write small k belongs to n natural. Okay, then this one is done. So we erase that portion and then going to further discussion of that. Okay, this one are understandable, that means problem. First we understand it, then this one is, that means this one is too easily we done. Okay, if we not understand, then this one is always, that means hard for yourself, that means critical for yourself. If you understand these problems, then this one is too easy. Okay, not a problem at all. So what we get, we also known again xn b cos c. Okay, then we know about that this implies that xn be bounded. Okay, any Cauchy sequence is bounded, then what happened? Then there exists m greater than 0 such that what? Such that norm of x infinity, that means with respect to this infinity norm, obviously norm of xn or not with respect to norm infinity less than equal to n for all n belongs to natural number. Not a problem at all. So this implies what? This implies supremum of k belongs to n. Here mod of xk whole to the power n less than equal to m, where n belongs to natural number for all n and k belongs to n. Oh sorry, k belongs to n, we write it in below. Okay, in suffix version of supremum. So here this one is right. Okay, not a problem at all. Supremum of this means this one is must be less than equal to m. Any problem? I think not a problem at all. Okay, so what happened in next? This one is taking limit as n tending to infinity. Taking limit as n tending to infinity, we get what? We get this one is xk, mod of xk less than equal to m for all n, not n is here, k belongs to n. Okay, here k belongs to n, we write, and that means right, then this one is better. Okay, so what we get? We get that each element of x must be bounded. So what happened? We write it here again. This one k belongs to n, this one is not written, no, this one is written, then beta. Okay, this one must be less than m, less than equal to m. Okay, taking supremum in both sides, here k is invariant and this one is not k variant. K obviously, that means not change this portions, so we write it in this way. Okay, you also say about that why you write here supremum, here not. This one not, that means foolish question, I think. Okay, if you're doing mathematics, so this one is obviously known about that. Then what happened? Then what happened? Then this implies that norm x infinity less than equal to m. Understand or not understand? This implies that what? X belongs to L infinity. Any problem here? Not a problem at all. So we write about that xn belongs to L infinity and xn b cos c and xn converts to x with x belongs to L infinity. This implies that L infinity complete. Okay, so L infinity be a Banach space. So L infinity be a Banach space. Any problem here? I think not a problem at all. So all I understand these portions clearly. I think L infinity with respect to norm infinity be a Banach space. Any doubt is here? I think no doubt at all. Okay, so today I'll stop here.